All right.
So many what?
Oh yeah, those are great tires. Put the phone away. Totally cool. Look at those things. Those are great. All right, so ladies and gentlemen, we left off yesterday. We left off yesterday doing a little bit of practice with binary nomenclature. Remember, we're going to look at everything. Everything in this class is going to be binary, a single cation and a single anion, something positive, something negative. Unless it's two nonmetals, then it's bonded covalently, so there is no cation or anion, which is the case for nitrogen trichloride. Okay? We only use prefixes when we have two nonmetals. And there's only 10 nonmetals. Easy peasy. Okay? So, like my squeezy in Japanese, eating mac and cheesy. So, remember, guys, remember, there's always a temptation to use prefixes when you don't need them. Only use prefixes when you have two nonmetals. So, nitrogen's a nonmetal, chlorine's a nonmetal, nitrogen trichloride. Barium chloride is simple in that it's just a metal, barium, and a chlorine for our nonmetal. So, barium chloride, don't need anything special. No Roman numerals needed, no prefixes needed. However, in cobalt bromide, we do need a prefix, or sorry, we do need a Roman numeral because cobalt's a D block metal. Because cobalt's a D block metal, we need to say what the charge is, and we realize that bromine has a -1 charge, so cobalt has to have a +2 charge. Okay? Again, rule number 1 for oxidation and nomenclature is that the overall charge of the compound must be how much? 0. Okay. So, oxygen, same kind of deal. Oxygen's -2, -2, and -2. That makes the whole negative side -6. Positive side is +6. There are 2 irons to make up the +6, so this makes it iron 3 oxide. Same deal with chromium phosphate. Phosphorus is -3, -3, -3 for a grand total of -12. The positive side has to be +12. There are 2 chromiums to make up that +12, so each chromium is a +6, and we show a +6 with a VI. Cool? All right, so that's where we left off last time. What I'd like you to do now is, on your paper, please identify the formulas from these names, and we'll do the first one together. So we're going to identify the formulas from these names. The first one is sodium oxide, the simplest of the 5. In writing our formulas, our best bet is to just write down what we have. So, what's the cation for sodium oxide? Nah. And what's the anion for sodium oxide? Oh! Okay, so, am I done? No, because the overall oxidation must cancel out to 0. Now, we know that sodium is in group 1, so sodium has a charge of what? +1. And oxygen, being in group 16, has a charge of -2. So, how do I rectify that? How do I make it balance to 0? Add another sodium. So the formula is going to be Na2O. So take a few minutes and see if you can bang through the other 4. We'll come back together in a few minutes. The little pieces that are on your desk are just kind of, they're manipulatives, like visual aids, if you want to play with them, but they're pretty great. We are going to play a game very similar to this when we play a game called Chemonos on Friday. Chemonos is super fun. Oh, you're going to miss Chemonos. Well, we might play it again on Monday when we get back from Thanksgiving. We might. And we also might play it on Friday, depending on how much work we get done tomorrow. So if I feel that you're ready for Chemonos on Thursday, we could play it on Thursday. Today is Tuesday, tomorrow is Wednesday. We're gonna do pretty much learn everything we need to learn today, and then tomorrow we'll just practice. So if I feel like your practice is good enough, then we'll play Chemonos on Thursday. No, 2 days. There's Chemonos and then pro Chemonos. 2 days of Chemonos. Where's your paper? Where's your paper for practice? I will throw this away.
Thank you.
Having trouble getting started? Okay. Don't do it in your head. Do it on paper. Write down the copper, write down the fluorine, and then make them balance out. So the +2 tells you the copper is going to have to be +2. Yep. This 2 tells you this is going to be a +2 copper. And fluorine is always -1. Where's your paper? Where's your paper? Okay. I think it's better to use paper. Oh, great. Okay. So you can just scratch paper right there. Where's your paper? Practice. No, your practice paper.
So there's 2 oxygen.
Because it's great if Sophia's going to pass the class, but we want everybody to pass.
No, that is 5.
So just write down write down the symbols, and then write down their charges above them, and then balance them out. Emily, do you have a question? Did you have a question? Okay.
There's 2 lines. Oh, that's the charge.
I'm not sure. Oh, fluorines. No, chlorine. I don't. Oh,
we're doing the bottom.
yeah.
Well, I figured you did some of the top.
Just tetrafluoride means there's 4 of them.
Mm-hmm. Yep. Yeah. D block. So you use the charge of +4 given to you in the formula, or given to you in the name. Use the lowest common multiple of 2 and 7. You made a formula! Okay, these are great, but let's do the practice too. You'll have plenty of time to play, but you also need to work on the in-class practice.
Oh, but then would you have to add another titanium minus 4?
Isn't it? Do you have a question?
Yeah. -2, so you get -4, and then titanium is 4.
I'm really confused.
Okay.
Sodium has -2, but oxygen has -2. So what am I trying to do?
No, sodium is in group 1, Na is in group 1, so sodium is +1. And sodium is Na, not SO.
I know that one.
So sodium is Na, and it has a +1 charge.
It does make sense.
Oxygen is O and has a -2 charge. So here's your O, and here's an Na,
I think I'm pretty funny too.
and here's an Na.
Oh, we need 2 NAs.
Yes.
Oh, so I'm just trying to...
I just like put it on it.
So is that that's when do I put it right here, or is that when I go like that?
No. You only use Roman numerals for the D block. You do put it after the symbol. So Na2O. So these are great, except this
I was just messing around.
and this are not binary.
But for this, that's a manganese +7, right?
Uh-huh.
So sulfur is like, it would be a -2 to get it not that.
Yep.
So how do you get? That'd be like a 3.5 element.
Kind of. Use the lowest common multiple of 14.
For D block metals, I'm always confused about their valence.
That's why you have to use the name. If it's a D block metal, it'll have the charge in the name. If it doesn't have the charge in the name, you're using the formula, you look at what it's bound to. So you do math that looks like this. So you can handle this math, right? Well, practice. Okay, one more minute.
How do you know, like, an element's charge? Like, how do you know?
Okay, that's a huge thing. Group 1 will always be +1. So lithium's group down will always be +1. Beryllium's group down will always be +2. The D block can be +1 to +7, and we don't know what it is until we look at what it's bound to.
Okay.
So if a single D block is bound to a -2, it has to be +2. And then boron's +3, carbon's group is +4, -4, nitrogen's group's -3, oxygen's -2, fluorine's -1. So +1, +2, +3, plus or minus 4, -3, -2, -1, +1 to +7. All right, so for the second one, the name tells us that it's copper 2, so copper has a +2 charge. Fluorine's always -1. How do I balance this? 2 fluorines. Bada bing, okay? And my puncher is, here we are. Okay, 2 fluorines. Boop, boop. All right. Carbon tetrafluoride. Yay, prefixes. What does the tetra mean? 4. And it refers to which element? Fluorine. So CF4. Titanium 4 oxide. Now titanium, in this case, it tells us is a +4 charge. It can be +4? Yes, it can be up to +7. So titanium's +4, oxygen's -2. So how do I balance this? 2 oxygens, and we're balanced at 0. And then manganese and sulfide. So we write our manganese and write our sulfur. Manganese, it tells us, is VII, which represents what charge? 7. So manganese is +7. Sulfur is in oxygen's group, so oxygen's group is -2. How do I balance a 7 and a 2?
You got another manganese, so it becomes an even.
Good. So now we have +14. And how do I make sulfur -14? 7. Okay. So yeah, one way is to use the lowest, I think the best way is to use the lowest common multiple. It turns out, as a means of shortcutting, I don't like shortcuts, but it turns out that if you just take the charges and swap places, then that'll also work. But I don't like shortcuts because people make weird errors when they do shortcuts. Use the lowest common multiple. Yeah.
So it's 2 manganese that you get?
You're going to need 2 manganese for a +14, and you're going to need 7 sulfur for a -14. Okay. Are we cool? Waiting. Okay. Oh, here. Boop. So, level 1, level 2, and level 3, check. Last thing. The last thing are called polyatomic ions. So polyatomic ions are big ions that move as a group. Okay? And they don't break up. They stay as a group. Are we ready to move on? Okay. So polyatomic ions are stable blocks that are exactly as they sound. They are polyatomic. They are multiple atoms that form a single ion. A polyatomic ion is a group that moves together through chemical reactions. IRL, there are hundreds of them. But we only care about the most common 7. Okay? So there are hundreds upon hundreds of them. We only care about the most common 7. Now polyatomics, they're a block. They move as a block. They don't get broken up. They have a single charge, and their formula doesn't change either. So we're still doing binary nomenclature. One positive thing, one negative thing. But now, the positive or the negative thing might be a polyatomic ion. and you actually have some. You almost certainly have some on your desk. You can identify some polyatomics. So look at your pieces and see if you can find a polyatomic in your pieces. You probably have more than one. Okay? The pieces are on your desk, Ellie, not on your phone. Okay, so first simplest polyatomic is nitrate. Nitrate has the formula NO3 and a charge of -1. Nitrate. This is my favorite. We use nitrates a lot. Nitrates are easy to get, easy to make. I'm sorry?
Yeah, let's make some nitrate.
Okay, we're going to use some nitrate pretty soon. Nitrogen compounds are a lot of fun, especially when they have lots of oxygen. So that's nitrate, NO3. Another negative is hydroxide. Hydroxide is OH minus. Another negative is acetate. Acetate is C2H3O2 with a -1 charge. So those whole things, those are all polyatomics. It functions as one ion. So you have a nitrogen surrounded by 3 oxygens, and it as a block has a -1 charge. You have an oxygen and a hydrogen, and it as a block has a -1 charge. You have a carbon and 2 oxygens and 3 hydrogens, and it as a block has a -1 charge. Okay? That's how polyatomics work. They work as a block. They move as a block. Now, my favorite -2 charge is sulfate. Sulfate is SO4 2-. It's a really big ion. For real. For all. For all? Yeah, for all.
F-U-R-L.
For all. To some people, far is a distance. To those in the south, far is a flame. If I say your house is far, most of you it means far away. If I say your house is far in the south, that means you better get home. Another -2 is carbonate, CO3 2-. Carbonate is CO3 2-. Again, 1 carbon, 3 oxygens, all moving together as a block, but now with a -3 charge, or sorry, -2 charge. My favorite polyatomic is phosphate. Phosphate! 1 phosphorus surrounded by 4 oxygens with a -3 charge. Now, polyatomics are not hard, but you do need to memorize what they are. Okay? And hopefully you will through practice. But if you're the kind of person who needs to make flashcards, it wouldn't hurt to make 7 flashcards. Lane, were you doing the ASVAB? Were you doing an ASVAB? No, just normal tardiness? Okay. Normal inexcusable tardiness? Okay, so those are the 6 negative charges that we're going to use in class. And there is 1 positive charge. You actually might, if you look down on your pieces, you actually might find a white polyatomic. It's only got a, nope, that's just magnesium. Yeah, there you go. NH4 is ammonium. I'm sorry that it's hard to see, but it's ammonium. NH4 plus is the only positively charged polyatomic that we're going to use in this class. All right, so how do we use polyatomics? Here's the great thing about polyatomic ions. Rome, there's plenty of space up front. You don't have to go back there and hang out with Alex. Okay, fair enough. Alex is cool. I would hang out with Alex. There's polyatomics are not hard. They don't get any prefixes. They never get any prefixes. You never say dinitrate, despite what you see on the side of vitamin bottles. We don't say diphosphate or dinitrate or anything like that. You never get any prefixes. Even though they're non-metals, you don't get any prefixes. Okay, so what is this? Yeah. No, don't do that. Never say sulfur oxide or anything like that. No, this is sulfate, and sulfate is a -2 charge. Copper is a D block metal, so we need to identify its positive charge from what it is bound to. I'll say that again for people who are looking at their phones. Sulfate has a -2 charge. It just always does. Copper is a D block metal, so we need to identify what charge it has based on what it's bound to. So, if sulfate's -2, copper is +2, and your formula would be copper 2 sulfate. Why do we have to use Roman numerals? Well, that's a good question. You could have, if I called the chemical supplier and I asked them for copper sulfate, there's basically 3 copper sulfates they could sell me.
Are those your drug dealers?
No, but that's your mom's drug dealer. Okay, so if I called my chemical supplier and I said I need some copper sulfate, there's 3 different copper sulfates they're going to sell me, and they didn't know which one. This copper sulfate has a copper with a +1 charge. This copper sulfate has a copper with a +2 charge, and this copper sulfate has a copper with a plus what charge? 4, yeah. There's 2 sulfates, so I can get copper +1, +2, or +4. These are all options that all exist. So this is why we need to show the Roman numerals to show what the charge of that D block metal is. Capiche? Okay, moving right along. That's copper 2 sulfate. What is that? Lean over and whisper to your neighbor what that is. Hopefully your answer was lithium nitrate, brush your teeth, you have bad breath. Lithium nitrate?
Ooh, roasted.
Yeah. And what is this? It's not zinc nitrate nitrate. It is almost zinc nitrate. It's almost zinc nitrate. What do I need to add to zinc nitrate to make it correct? Zinc dose nitrate? Yeah. Zinc nitrate. Okay, so I have some puzzle pieces up here for us to study. What I'd like you to do is I would like you to write the name of the compound that I have up here. I have 1, 2, 3, 4, 5, 6 compounds. If you can't see, this is C2H3O2 down here. I'd like you to write the name of the 6 compounds down here and the formula of the 6 compounds right here. Can you handle this?
Possibly.
Okay, so on your paper, utilize the time well and write those 6 compounds down, and then we will practice together.